After the spark transmitter, the continuous wave, the carrier transmission, came about. Spark transmitters, as explained, were unable to provide continuous waves, so they could not be modulated with audio. Valves were developed, and this provided the continuous carrier, and the time of the RF signal can be as long as wanted by holding down the Morse key. This carried modulation in the form of CW, continuous wave, using Morse code. Although it doesn't actually carry anything other than the means to communicate using the breaks in the transmitted wave. That was a concept by some that audio is carried by the transmitted wave, whereas in reality, audio modulation is the result of sidebands sent along with the main carrier. The carrier, the main signal shown in the center of the three signals, serves no purpose other than to provide a frequency reference and an initial power level setting. The information, the voice, is the result of the difference frequencies between the sidebands and the main signal carrier. This shows the signals as voltage levels for an AM amplitude modulated signal, and the two outside voltages is a modulated information, and both signals are identical. As can be realized with sideband, SSB, only one sideband is needed for ham quality communications, and the main signal is not required other than for reference or setting up. There are several ways of creating a single sideband, and I will just explain one of them by using the balance modulator principle. At first glance of the circuit, it appears that the two transistors are in push-pull. Look at the carry input transformer, and you'll see that one end is connected to deck, to earth, and the other one goes to the center tap, the base of the two transistors. When there's an input to the carrier with no audio input, the signal to the center tap of the transformer goes to the top transistor and the bottom transistor. They're both in phase. So what happens is the top transistor turns on and the bottom transistor turns on at the same time. When there's a signal to the carry input transformer, the one end, as you see, goes down to deck, and the other one goes to the center tap of the transformer connected to the two bases of the transistors. So consequently, when the signal at the center tap of the transformer is positive with respect to the earth, then both transistors are turned on. Positive signal goes to the top transistor, and the positive signal goes to the bottom transistor. With the both transistors turned on, the same voltage is applied at both collectors, and consequently at either end of the output transformer, the DSP output transformer, DSP double sideband. So there is no output. With audio applied, with no carrier input, but we have an audio signal input, this now appears to be the normal standard push-pull transformer, with the center tap of the transformer now going to earth via the or through the coil of the carrier transformer. Either end of the transformer, of the audio transformer, one will be positive and one will be negative, so that works as a normal push-pull transformer, push-pull circuit. But although the output at the output transformer, DSP output transformer, is correct, audio cannot pass through because the output is tuned. You notice the two variable capacitors. Let's say that's tuned at, say, 1 megs. And we've got an audio frequency of somewhere between, 200 cycles up to 3K, 3,000 cycles. Hertz. It hurts me to say hertz. Anyway, right, so audio will not pass through because the tune circuit will not allow it. This means if there is an audio signal but no carrier input, no audio will pass through. Consequently, if there's no audio input but we have a carrier signal, again, no signal will pass through. We have a condition called a balanced modulator. It is balanced. Everything is in balance. We need to unbalance it. And the way to unbalance it is by applying the both signals. When both signals are present, the carrier input and the audio input, the carrier provides the biasing for the transistors and the audio input provides the modulation in the normal push-pull way. The transformer will allow the audio to pass through when the carrier is there. The output from the output transformer, DSP output, will only pass the audio when the carrier is applied. No audio, no output. No carrier, no output. The carrier input creates a balanced situation and the audio creates the unbalanced situation. So the carrier switches the circuit on and the audio has got the normal push-pull type situation. So the audio will appear at the output of the transformer, DSP output. The output will be audio on both sidebands but no carrier on its own because that's been balanced out. The output of the exciter produces double sideband because of the mixing process. So it needs filtering to remove one of the sidebands.
1 PW8 Arrow 2J Golf Whiskey 8 Lima Julia testing PW8 Golf Whiskey 8 Lima Julia testing 12055431. This is the GW8 Arrow 2J Golf Whiskey 8 Lima Julia testing with the polyphase transmitter.